Very good morning, my dear friends. A hearty welcome to my YouTube channel and myself, Dr. M.H. Annaya. Friends, in today's session, we are going to work out a problem on a square lamina in which the lamina rests on one of the corners on VP and the opposite corner on HP. Friends, the lamina is resting on a corner on HP indicates that you have to place the lamina on HP such that one of the corner of that lamina will come to your left. Say this A will come to your left. Obtain the top and front views of the lamina. In the top view, you get a square with all the four sides of the lamina equally inclined to VP. And in the front view, you get a horizontal line. Maybe if you keep like this, you will get the diagonal as the length of the front view. So let me write this square in the top view with one of the corner A coming to the left side of the observer. So friends, this is the lamina we have got in which all the sides of the lamina are equally inclined, means 45 degree, 45 degree, etc. So this is 45 degree. This we can call it as A, B, C and D. Friends, I am placing the lamina on HP such that the corner A is to the left side of the observer. Friends, obtain the corresponding front view. Front view is going to be a line of length equal to the length of the diagonal of the square lamina. So we will call this as A dash. B and D lie on the same line. So we will call it as B dash D dash. And the last point is C dash. Friends, the lamina is placed on HP with the surface or with the edges equally inclined to VP. And we have got the front view and the top view. The length of the front view I show here by a term called M. M is nothing but the diagonal here. This can be measured using a scale. Friends, he says the surface of the lamina is equally inclined to both HP and VP. That is to say, the surface is this ABCD. It makes an angle of 45 degrees with the HP and also 45 degrees with the VP. That is, finally it will be something like this. So it will be making 45 with the HP and 45 degrees with the VP. Friends, what we do now, we have the surface of the lamina. I just represent this point or show that point here, A dash, and draw a line here of length is equal to this M. So M is nothing but the length of the diagonal. And remember friends, these two lengths will always be same in all the laminae. So the points here is A dash, the last point is C dash, and exactly in between you have got this point B dash and D dash. B dash and D dash. And this angle I have shown here, the angle made by the surface of the lamina. So since it is equally inclined to both HP and VP, this is going to be 45 degrees. Friends, the figure I had here, figure number 1, is redrawn here as the surface inclined at 45 degrees to HP. We obtain the corresponding top view. So I just write down these lines from there. Friends, let's get the points one by one. Now to get point A here, a horizontal line from a vertical line from this A dash, the point of intersection will give you the point A. Similarly, vertical line from C, the horizontal lines from C will intersect here and you get the point C. Then B is, that is horizontal line from B, vertical line from B dash, the point where those two intersect will be the point B. Finally, you obtain this D. So the point of intersection of the horizontal line drawn from D, the vertical line drawn from D dash will give you this point D. Friends, these A, B, C, D will represent the four corners of the square lamina when the surface is inclined at an angle of 45 degrees to HP. So let us join all these. So I will join A to D, A to B, and this is C to B, and this C to D. Friends, if you observe these two figures, you will observe that all the dimensions of these sides are reduced, and the lateral dimension AC, which was a diagonal, has got reduced depending on this inclination. Friend, here you got the front view, you have got the top view. Now the surface of the lamina is making an angle of 45 degrees with the HP. Friends, he says this C dash should lie on VP and A dash on HP. Friends, what I do, I am going to redraw this rhombus, the top view obtained here, such that this AB or the corner A will be here and C comes here. So I am going to redraw this figure here with this AC, which is parallel to XY, becoming vertical to XY. So friends, I will just draw like this. AC vertical. The same figure is redrawn here, taking the same dimension. Only thing is, this point is A, will be here, and opposite to that is C, this point. You can have B here or here, it doesn't make any difference. It is B and this point is D. So friends, the figure I have drawn here, the rhombus, these two are same, but corner C touching the vertical plane. So friends, finally, let's get the points in the front view. So vertical line from A, a horizontal line from here will meet at this point. We will call this point as A dash. Similarly, horizontal line from C, vertical line from C will give you the point C dash. B and D are here. So draw a line exactly passes through the center of this. So you will get point B here and get point D here. Friends, you can see here, this is the point D, that's D dash, this is A dash. Finally, this is the point B dash. Friends, we have got all the four corners of the figure in the front view, join them by straight line. Friends, here this rhombus we have got here, A dash, B dash, C dash, D dash, will represent the final front view of the lamina, and this rhombus ABCD will give you the final top view of the lamina. Friends, you can observe here an important thing, that both of these two figures will be exactly identical, because when the surface is inclined to both HP and VP equally, you are going to have figures which are totally identical to each other. And friends, finally, to check whether the solution you have got is right or wrong, let's check it now. The lamina is stretching HP. So since it is on HP, in the front view, you should get it as A dash and A. And the vertical plane is touching the corner C, or C is touching the vertical plane. So C is touching the vertical, because whenever you have got a point on the vertical plane, it is seen in its top view on the XY. And hence, whatever the solution you have got for this problem, when it is touching the VP and HP by the opposite corners, is completely satisfied. Friends, I hope you have followed the procedure to obtain the projections of a square lamina in which one of the corners touches HP while the corner opposite to that touches VP, with the surface making equal inclination with both HP and VP. Friends, if you are happy with the presentation, Do subscribe to my channel and share this information with all your friends and help me to grow this channel. Thank you very much.